our very first BSides Athens. Today I'm going to talk to you about Evil Twin attack. The presentation is called Getting the Most Out of Evil Twin. So, some things about me. I work at Census. Census is a Greek company that provides specialized IT security services to its customers. I'm interested mostly on cryptography, Wi-Fi hacking, web and network security. I'm involved in some academic research, mostly designing privacy enabling and anonymity providing protocols. I am the lead author of Wi-Fi Feature, a tool that involves Wi-Fi hacking with basic attacks. Wi-Fi Feature was first introduced last year at BSides London. So this presentation now is the continuation of that presentation that I did last year. So the four main topics that this presentation revolves around is first of all the Evil Twin attack, what it is and how it performs against different kinds of networks. Then we're going to talk about denial of service attacks on Wi-Fi. This is complementary for the Evil Twin attack. After that, we're going to talk about some special phishing scenarios that phishing attacks that we can mount that make very much sense to do when using Evil Twin attack. And finally, we're going to see some new features on Wi-Fi Feature, and how exactly it works after a year. So, the Evil Twin attack. The Evil Twin attack is very easy to explain actually. So, you actually use a rogue access point, the attacker will use a rogue access point that behaves very legitimately. So, in order to gather personal or corporate data. So, for example, if right now we have I think a Wi-Fi called BSides Athens, what an attacker can do is set up another and a second with his Wi-Fi router, for example. He can set up a network called BSides Athens, the same SSID, and with that way he can get victims connected with his network, and he will have an easy man-in-the-middle. This is a very common attack vector in Wi-Fi environments. Most setups are vulnerable by default. There is no easy user-oriented method that mitigates from this attack. And this diagram here actually shows you the attacker is bottom left. So the attacker actually tries to convince the victims that he is the actual legit access point. And at the same time, he's trying to deauthenticate using denial of service attacks. He's trying to kick the victims out of the legit network so he can get him connected to the rogue access point. So the first thing when it comes to Evil Twin attack is getting the right equipment. This is a very important step. Because when it comes to Evil Twin attack and rogue access points in general, what you want to do is to have victims connected to your network. And the most important factor for this is probably the signal that you have. So getting the right equipment is a very essential step. The golden rule here is that the more power gain that you have, the better. That's very simple. So ideally, in the best case scenario, the attacker will have 2 attack points. So if the attacker targets an infrastructure, for example, he will use one attack point that will be from inside the infrastructure, and he will spawn the rogue access point from inside the infrastructure. And he will use probably an omnidirectional antenna for this, so it can broadcast the access point all around. Of course, it should be well hidden for prying eyes and has a low battery consumption. So yeah, it could be a Raspberry Pi or a Wi-Fi download, for example. And the other attack point should be from distance, using a directional antenna. It will be like from outside the infrastructure, outside the building. So you have 2 attack points, one for spawning the rogue access point and one for the denial of service attacks. But the dark case is that you can use the same attack point and still the attacker can have very good results. So there's something called the auto-connect flag. This is what is happening whenever you connect to a Wi-Fi, and then you go away, and then you come back to that Wi-Fi, and your device automatically connects to the same Wi-Fi. This is because of the auto-connect flag. I'm pretty sure you're familiar with this. This is enabled by default. It's a typical usability over security feature. And what we're trying to do, people to in most of the times, is that we're trying to exploit this flag and make use of this. So right here, down here is a setting. This is, I think, from Ubuntu Network Manager. And yes, this flag is enabled by default. So let's see, whenever you turn on your Wi-Fi feature on your device, there's an algorithm that actually chooses the network that your device will connect to. And the algorithm is pretty simple. They want, first of all, he will look for an ESSID. ESSID is the network name, right? He will look for an ESSID that already exists in its preferred network list. The PNL is a database that's stored in the device. It has all the networks that it has connected to. So it will look first for a network that it has already connected to in the past. That's the first thing. But if there are more than one, if there are like 5 networks that this device was connected to in the past, the device will choose the one with the best signal, that offers the best signal. So what the attacker, of course, wants to make the automatic association with the victims, right? So these are the two things that he wants to achieve. The second one, first of all, is to have a good signal. We already talked about this, how he can get the good agreement for this. About the first one, he wants to have something that already exists in the victim's PNL, preferred network list. So in order to achieve number one, we need to understand what exactly the devices are adding, the network managers are adding to these PNLs. This is actually an association of the ESSID, the network's name, and the encryption type. So for example, if I now connect to the BSides Athens that we have here, I think it's a WGate protected network. So my device will store to its PNL an association that is BSides Athens, the SSID, and the encryption will be WGate. That means that in order to connect to it again, automatically, it will need to find a network with these two parameters. First, the SSID should be the same, and the encryption should be the same. So that's what the attacker needs to do. Let's see how people can work against open networks. First of all, many of you may wonder why I want to target an open network. The thing is that this is an easy way to get money in the middle. For example, ARP spoofing is another way, but sometimes there are mitigations against this. There are limitations, network protections. So, spawning a rogue access point is at some penetration tests it's easier for having the victims connected to it. So the open networks are usually employed along with the captive portal mechanism, something like that down there. You have seen that probably in hotels or airports or offices. This is by default vulnerable to our attack we built in. Because both the SSID and the encryption type is open, can be very easily replicated. So the only thing that the attacker needs to worry about is a stronger signal. As soon as it has a stronger signal, victims will connect to it automatically. So yeah, most setups are by default vulnerable to this. About WPA or WB2 with known or compromised Preshared Key. This is common in conferences. Right here we do have a network that the Preshared Key is disclosed, for example. And there are other infrastructure that do this as well. So they have a pager or something with the Preshared Key. And of course, because we do have an authentication with many parties, and the authentication relies on a single Preshared Key, this is a secret that if it's compromised by the one endpoint, the other endpoints are exposed. They may never know. They don't have the knowledge that the preshared key has been compromised. So this is very common to have a network that the preshared key is compromised. So if you're in that case, that there is a WGate or WGate protecting, and you do know the preshared key, then again these setups are vulnerable to evil twin, because again we can replicate both the SSID. For example, here what the attacker would do is to set up a Wi-Fi network with the SSID besides Athens, and the encryption type will be WP2 with a password that everybody knows right now, the preshared key. So again here, what the attacker needs to have is a sluggish signal. This is with not that much money, he can get a very good signal. Corporations will see that many corporations will employ WGate enterprise. This is whenever you don't use a preshared key to authenticate the access point. Instead of that, you're using a username and password or a certificate. This is again vulnerable to evil twin attack, because the attacker will set up the same ESID and the same encryption type. And he will set up a radio server as well that he will always say, yes, okay, authenticate him. I don't care about the credentials. So that's the way that he will trick the victims to connect to the access point. The only case that this is not going to work is whenever the corporation is leveraging PEAP or EAP TLS. When that's the case, the attack will fail because the victims actually authenticate the access point. So this is a pretty good mitigation against the evil twin attack. And if the certificate is not known to the device, then the attack will fail. So in the cases that the attack does not fail, the attacker can get the man in the middle position, of course, and he can also capture the challenge response that is happening in this kind of protocol, and he can brute force that offline later in order to retrieve credentials and access to the blessed network. So that's probably what's happening whenever the attacker targets a network that is WPA or WP2, and he doesn't have access to the preshared key. He doesn't know the preshared key. That's probably the most interesting case, and it's a very common scenario. So what is not going to work? We do know the ESSID, but we can't replicate the same encryption. Yes, we can set up a network with WP2, but we don't know the preshared key. So if we just put a random preshared key there, this is not going to work. This will fail because the access point won't be able to decrypt the packets from the client. The client will use a different preshared key, and the association will fail. So this is not an option. We cannot set up a rogue access point that has a different preshared key than the target access point. So what is common there is to do a downgrade attack. Downgrade attack means set up a network that has no encryption, and these attacks usually need some victim interaction. You just want to push the victims to click on the open network in some way. So there's the karma attack that is very well known. So right now we're actually, because there's not an easy way to replicate a network that we don't know the preshared key, the attacks that we're going to see now are actually oriented to the users themselves. So karma is an attack that is targeting the user instead of the access point. This is featured by Wi-Fi Pineapple. And what it does is listening to probe request frames. Probe request frames are the messages that your device is sending every time you turn your Wi-Fi feature on. And it's a way for your device to say, I'm looking for access point, Mumble, I'm looking for access point, whatever, besides London, besides Athens, etc. So what Karma is doing is actually listening to this probe request. This is an information leak, by the way. Your device does this, in case you don't know. So what Wi-Fi Pineapple and Karma attack is doing is listening to these probe request frames, and it can determine in a way if this probe request frames are intended for an open network or a password protected network. If they are for an open network, they will just spawn that network, and the automatic association will happen. If it's not, if it's for a closed network, it will do nothing. It will keep waiting there as soon as it encounters an open network. Of course, in order for this to work, the devices, the laptop or the mobile phone, needs to have already stored some open networks in the PNL, needs to have already connected to open networks. So this scenario, for example, if BSides happens around, that's what your laptop is going to ask. From now on, you have connected to the network and you have the default settings. And the Wi-Fi backup, if the BSides happens was open, it's not open, so we're good. If it was open, then the karma attacker will say, yes, I'm here. You get man in the middle that way. The thing is that karma attack is not working as it used to be. That's not surprising, because karma was first announced, or first written, like the paper was disclosed 10 years ago. And the reason that this is not going to work is that devices will wait for the correct beacon frame first before setting the probe request frame. What's the beacon frame? The beacon frame is the message that the access point is sending, saying information, announcing its presence. So that's the correct way. So down here you see the correct way. The device first waits for the access point to say, hey, I'm BSides Athens, I'm around. And then it will say, cool, okay, I have in my preferred network list. Now I can associate with you. That's the correct way. The other thing that devices are doing, I've seen that mostly on Android devices, is that they send probe, if they do send probe request frames on their own without getting the beacon frame first, they will put in the destination address the broadcast address. So there is no ESSID link there. The attacker can't know. The broadcast address means that this message is intended for everyone around. So there is no information link, ESSID link there. So karma is going to fail again. From my experience, karma works good against Apple devices, but not, for example, Windows 10 or Android.
iOS?
No, last time I tried, didn't work. So what can, something that we can do, and some people don't actually realize this, is that an attacker can guess the ESSID. So right now we don't target a network yet, we target a specific user. If the attacker has a knowledge that the victim has connected to an open network, for example, if someone was in BSides London conference and there was an open network there, I can assume that the victim connected to that network. It's very easy to go outside of the victim's house and set up a network called BSides London. The victim will, if I have a strong signal, the victim will connect to me. So yeah, it's very important to know in which networks we are connecting. This is a very easy to do attack. There's another attack that makes this even easier. There's a flag, apart from the auto connect flag, there's another flag that makes, this is also enabled by default on modern network managers. And this actually makes the network that you're connecting available to all system users. So that means that, for example, in a corporate laptop that more than one people are using, someone may profile or target the other system user, and by getting the information, for example, that the other system user went to BSides local, you can target all the rest of system users by getting this knowledge. All right, let's see some things about the denial of service attack that we can do. The most common is the authentication attack. So there's a frame called the auth frame. This is transmitted and encrypted in the air, and is sent when the access point wants to reboot or have a firmware upgrade. It will send that to all the stations, claiming that you guys need to disconnect now. and it's also what the device is sending whenever you leave the network. But because there's no encryption there, anyone can corrupt its messages, send them to the air, and he can kick out lines that way by sending 3 field frames, one from the access point to the client, one from the client to the access point, and one from the broadcast address, just to make sure. So, yeah, of course, this is a good attack that is working. Of course, we can do physical jamming as well. We can play with the radio frequencies and do physical jamming. I like this better because you don't need a special device or something. You can do that from your Linux, from your Linux machine, for example. So I told you earlier that if you do a downgrade attack, if you set up an open network, there won't be an automatic association because the encryption type will be different. So in that case, you actually need some user interaction. You want the user to see his device, to see his network manager, and click on the network. So to do that, you actually, in this attack, you are targeting a victim again. You're not targeting the access point. What can you do is actually, as soon as you deauthenticate the station, first of all, with the previous attack, what's happening is that you will deauthenticate the victim, but you will get connected again because of the auto-connect flag, unless you have a stronger signal or something. But this will keep happening, right? This will be annoying for the victim, but we can also, what it will probably be better if we want manual interaction, is to set up a network with the same exact encryption settings. So we set a random preshared key. As we said, we won't have automatic association, we won't have automatic connection there. What's going to happen is that the victim will try to connect to our network. So we're actually going to respond to probe request frames. This is the same thing as setting up the same network, just with a different preshared key. And what's going to happen is that if we have a stronger signal, the victim will try to connect as soon as he gets authenticated with the first jamming attack. The victim will try to authenticate to our network, and because we don't know their preshared key, we will say, sorry, your PSK is incorrect. But with that way, we have the victims disconnected, and not disconnected and connected to the correct network, disconnected. We'll keep them disconnected that way. And this is probably better if we want them to manually interact with the network manager. All right. We can see some phishing scenarios, and then we can proceed to some more interesting stuff on Wi-Fi feature that we have implemented. So we can, of course, as soon as the attacker gets man in the middle with the rogue access point with the able to in, he can perform many attacks. He can sweep for sensitive data. He can infect the victims with malware. Something very cool is the phishing, because of many reasons. He can do a lot of different kinds of phishing. For example, he can pull captive portals. He can clone the captive portals and put his own. He can set up, for example, a free Wi-Fi rogue access point that he will force the victims to use their own credentials, their Facebook credentials to log in, and he can get Facebook credentials that way. These are all cool scenarios. There are some scenarios, though, that are very interesting, and they have to do with bridging information from the air, from the beacon frames, to the template. These are very interesting because these are actually something that you can do manually. Wi-Fi Feature, the tool that I wrote, does this in an automatic way, and it's very hard to do manually. So what we're doing is getting information from the beacon frames. The beacon frames, again, are the messages that the access point is sending. And we're using this information to make an automatic template generation. So let's see these scenarios in more detail. The first thing that we can do is to identify the vendor with the MAC address of the access point, and then display fake messages coming from the router, but for example, asking for the WPA or WPA2 preshared key. But by getting the MAC address, we can determine the vendor of the access point, if it's Cisco, for example, and we can make this much more realistic. We'll see that in practice very soon. The other thing that we can do, and it's pretty cool, is that we can imitate the network manager we can show, the first thing that we will do is show a connection fail page at the beginning. So first of all, we can keep doing internet connection, right? We have a road access point. We can give a valid internet connection to the victim. At some point, we can drop a connection fail page, like the one that browsers are showing whenever you don't have internet. And we can know what browser the user is using, because we can get that from the user agent data. So the first thing that we're doing is, after a while, after some browsing on the internet, we will throw this page. The second thing that we will do is to display network manager asking for the WGate password. But we will display this network manager on the browser. We will display that with our own HTML and the JavaScript code. But we can make that very realistic, so the victim won't really realize that this is the website instead of the operating system. And of course, network managers are different. The graphical user interface is different. We can determine which operating system we should mimic by the user agent header again. And we can also fill this network manager with information. For example, the beacon frames that are around. This is the briefing that I was talking about earlier. We do know what networks are around. So we can, for example, on Windows, if you click on the network manager, you will see the networks that are around, right? So we can do that. We can get the networks that are around, and we can make a network manager on the web page that way. So let's see Wifiphisher. Wifiphisher automates the filtering. It does all the road access point and the Wi-Fi jamming. It is very supported by Wi-Fi hacking community. And we are having a 1.2 release. I'm going a little fast right now because we don't have much time left. This is how the tool looks like. So a feature that we have is the template customization. Right now, someone may, a basic page designer can provide a config file that can be filled by the user. And for example, if the user of Wifiphisher does know information, for example, the firmware version, somehow from another channel, he can use that information. The designer, so we have a template engine, a new version of the target access point vendor, and this will be rendered like that. So here we have a new version of the circle firmware, and we got that from the air. We got that information from the air. This happened automatically, right? And firmware, here we have the version of the firmware. The user can put information there. So another feature that we have in the new release is the parsing. A lot of tools are using are relying on IW or IP company and parsing these commands. We're actually using parsing now. That's a Python library that communicates with the kernel to get this information. This is a very cool project that is supported by Wifiphisher. It's a very new project, and it's something that makes the tools very much stable. So the third feature that we have is that we have some user ways, as I told you earlier, that are pretending that they are from the user. I can show you some of these. Let's see the old sets one. Example. So here you see, you got the page that there's no internet connection. This HTML file recognizes that I have Firefox, so draw something similar. And this is not Mac, right? This is the one for Macs, for targeting a Mac laptop. And you see this is very much, let's say this is very realistic. You can't see any difference here. It looks very valid, right? And I can show you another one too, for this that is currently being worked. This is for Windows 10. So you see, it's very realistic. If you see here, the valid one is this one. We're close enough, right? We're getting there. So these were actually made by Dionis Zindros, the guy who presented earlier. He's sitting right here. All right. Alright, so yeah, that's the last slide. We do have a mature open source community behind that. There are a lot of contributors. Some of them are around. We did our first hackathon a week or two ago. It went pretty good. We had a lot of fun. We're always looking for new members, so if you're interested in working on that, you can contact me. Yeah, that's pretty much everything. Questions? Yep.
I want to ask about the authentication frame. You need to be a member of this openness team.
No. That's a cool thing. Because there's no encryption there, you can just grab these deal frames and start kicking out lines. Yep.
The network management page, so you have one for each version of the Windows, let's say?
That's the plan. Right now we have these two network managers, but the plan is to have everything. This needs some advanced skills, say HTML5 and CSS3. Dionys has skills, so he can tell us. Yes?
You said that devices send out probe requests for known access points that they have passed. Do you know if there is any effort? I think Apple has done it somehow to either change the MAC address, so you don't know who sent the probe request.
Right, so
Windows Phone can disable it, I think. Is there any effort from Android?
First of all, if you connect to a network and you uncheck the remember this network,
yes,
it won't go and ask for this network again. That's the one thing. The other thing is that I told you that Karma is not working, and the reason that's not, one of the reasons that it's not working is that yes, devices are not going to send on their own probe request frames. They will first listen to the beacon frame, and then they will send probe request frame. So yeah, it's a lie to say that all networks, all devices, all network managers are currently sending probe request frames from previously associated networks. That was true like 5 years ago, but now they have countermeasures for Karma, so they are not really doing that much anymore. Yes?
So Wifiphisher helps you with template customization. It captures the packets.
So Wifiphisher does all this. I mean, it stores the rogue access point, it kicks out clients from the network, and it helps you with the right and late right scenario. We have lots of scenarios. We have scenarios for grabbing the Preshared Key. We have scenarios for feeding the victims with malwares due to plugin updates, for example. We now have these scenarios that imitate the browser. We have many scenarios that are many more to come. So it does all of these that we discussed. Thank you. Yes?
You told us about the power of your network a lot, so this is crucial, I would say. But especially in enterprise environment, they have a lot of access points. From my point of view, it's very difficult to overcome this power. So if you can flow this access point, a specific access point with request, like a denial attack, a device that would have sent a rogue Wi-Fi protocol, when you try to connect to the phrase that has been floated, will you try to reconnect to your?
Yes, indeed, there are some attacks like the one you said. For example, you can do an association flooding. You can pretend that you have many clients and that they want to connect to this network. This is a common attack that you can do. And that, of course, the first thing that the attacker is going to try in the enterprise network is to have to deny service completely the access point.
Yes,
A common attack for this is to pretend that it has many clients that they want to associate with them. This is a very common attack. It works in many routers, from my knowledge, in many access points, but not for everyone. So yes, this is a common attack. They will try to deny the service that way. If they do have access to the network that this access point is providing, they probably can try other exploits depending on the vector in order to bring this completely down. That's the first thing. If all of this fails, I think the attacker is going to try probably physical jamming if it has the hardware. And if it's an enterprise network, that means in a large corporation, physical jamming makes sense for a determined attacker. Otherwise, he can do the simple deoffing that we talked about earlier.